Hello everyone, welcome to this video on molality. We are going to learn its definition and see how to derive the mathematical relationship between molality and mole fraction. So let us get started. We know that a solution comprises of two components, its solute and the solvent. Molality is the concentration term in which we express the number of moles of solute present in a given mass of solvent. This mass is expressed in the unit of kg. So please note here that the number of moles of solute is expressed with respect to solvent, unlike molarity where the number of moles of solute is expressed with respect to the volume of solution. Okay, so this is the major difference between molality and molarity. In our previous example, we have dissolved 10 gram of sodium hydroxide into 250 ml of water. We have labeled its molarity. Now it is time for us to label it in terms of its molality. So 10 gram of sodium hydroxide will be equal to 0.25 moles and 250 milliliter of water is equal to 0.25 kg. Putting these values in the definition of molality, we will get 0.25 moles of solute divided by 0.25 kg of water, that is the solvent. Hence this solution will be labeled as 1 molal. Okay, 1 molal. Molality gives us the information that how many number of moles of solute are present in 1 kg of the solvent as per the definition. We will utilize this information in a number of numerical problems. Let us now see how to derive the mathematical relationship between molality and mole fraction. For a solution, what is known to us is number of moles of solute, number of moles of solvent, and molar mass of solvent. We will try to express the relationship in terms of these variables. Also, let us note down the definition of mole fraction for our reference. Now, let us begin from the definition of molality. Molality is given by number of moles of solute divided by mass of solvent. We have to express molality in terms of mole fraction. So at this point, think about it that how can we bring the expression of mole fraction within this definition. One way of doing it is if we divide both numerator and denominator of this expression by total number of moles, then we will have the expression of mole fraction of solute into the numerator like this, isn't it? Now our next task would be to eliminate mass of solvent. We will also like to bring the mole fraction of solvent into the picture. So let us replace mass of solvent by using the expression M solvent equals to number of moles of solvent times molar mass of solvent. Let us substitute this entire expression. Then we will get molality will be equal to mole fraction of solute divided by number of moles of solvent times molar mass of solvent upon total number of moles. Okay. The mole fraction of solvent is given by number of moles of solvent divided by total number of moles. So we will club N solvent and N total together. This will become the mole fraction of solvent. So the entire expression will change as like this. Molality becomes equal to mole fraction of solute divided by mole fraction of solvent times molar mass of solvent. So this is the expression of molality in terms of mole fraction of solvent and solute. Okay, we can further simplify it by using the relation mole fraction of solute plus mole fraction of solvent equals to 1. So mole fraction of solvent can be eliminated by replacing it with 1 minus x solute. And as per the definition of molality, we express the mass in terms of kilogram. So there will be a conversion factor of 1000 introduced. Okay, so our final expression will be molality equals to x solute upon 1 minus x solute times 1000 upon molar mass of solvent. With this entire relationship, we can relate molality and mole fraction of solute. Okay, we will note one point here, that here molar mass of solvent is to be written in terms of gram, because we have already included the conversion factor 1000 in this expression. Okay, thank you so much for watching. In the upcoming video, we will be discussing a new concentration term, normality. So see you in the next video. Thank you once again.